Hello. Today we want to learn together about the argentometric methods. Um, First, we start from the introduction of these chapters. In general, the titrations governed by precipitation reactions do not really constitute an appreciable number in volumetric determinations in comparison to either redox or acid-base reactions. The interaction between silver nitrate and sodium chloride in solutions resulting to the precipitation of silver chloride as shown below. Sodium chloride plus silver nitrate result in silver chloride precipitates and sodium nitrate. In actual practice, however, such titration are more or less restricted to those involving precipitation of silver ions with anions. For instance, halogens, chloride, bromide, iodide, and thiocyanate, SCN-. Generally, it is quite difficult and tedious to locate the exact point at which further addition of the reagent affords no more precipitations. Therefore, the choice and wisdom of the chemical reaction is preferably soft so as to result in either a colored solution or uncolored precipitate at the end point. A typical instance may be cited by application of potassium chromate K2CrO4 solution in the above case, whereby any extra drop of silver nitrate after all the chloride has been precipitated immediately cause precipitation of red chromate, showing that the endpoint has been duly achieved. It is, however, interesting to observe here that such reactions do offer limited usage because of the following two facts, namely, co-precipitation effects do not give a real composition of the precipitate, and the second is a choice of appropriate indicator is very much limited. Besides the foregoing facts, another vital aspect to be taken into consideration is the solubility product that plays a major role in such titration. Hence, the equilibrium constant of the reaction giving the precipitate of silver chloride may be expressed as silver chloride solid is going to silver ion aqueous and chloride ion aqueous. The equilibrium K constant is silver cation concentration multiplied by chloride anion concentration divided by silver chloride concentration. From the above expression, the solubility product constant Ksp may be designed as Ksp is equal to silver cation concentration multiplied by chloride anion concentration, assuming the activity of solid silver chloride being constant. Okay. Following are the four cardinal parameters that may be considered for a feasible argentometric analysis, namely, precipitate formed must be insoluble, precipitation process should be fast and rapid, and co-precipitation effect must be minimal, and detection of equivalence point must be apparently visible. The theory. In the precipitation reaction involving chloride and silver nitrate, the addition of even a small quantity of the latter shall affect precipitation of silver chloride, provided that Ksp has been exceeded significantly. At this juncture, the concentration of both silver cation and the chloride anion color and ion are related by the solubility product equilibrium constant. Thus, we have silver cation as a tetrand and color anion as an analyte to the equilibrium of silver chloride in a solid form. Chromate ion concentration required to initiate the precipitation of silver chromate in a Ag2CrO4 commences at the equivalence point and may be calculated with the solubility products for AgCl or silver chloride and silver chromate. AgCl, silver chloride KSP is 1.8 multiplied by 10 to the power minus 10 is equal to silver cation multiplied by chloride anion concentration, and silver chromate KSP is equal to 1.2 multiplied by 10 to the power minus 12 is equal to silver cation to the power 2, because this is 2 here, and multiplied by silver chromate ion concentration. Assuming that at the equivalence point this silver cation is 1.3 multiplied by 10 to the minus 5 molar concentration. The chromate ion concentration must be silver chromate here without any minus divided by silver cation to the power 2. And how it's coming, or 1.2 multiplied by 10 to the power minus 12, these parts, divided by 1.3 10 to the minus 5, this one, to the power 2. See, these are the constants from the table. Okay, now why this to the power 2? Because of this formula, because this one Ag2CrO4, and why this is 1 okay, this is Ag2CrO4, this is Ag2 constant, this is AgCrO4. I don't know how it's coming. We want to find this, and this is this one, but how to find this? In actual practice, the concentration of chromate produces an intense yellow color to such an extent that the end point is masked. Therefore, normally concentration of 5 multiplied by 10 to the minus 3 molar are employed in the analytical procedures. It suggests that silver cation shall be more than 1.3 multiplied by 10 to the minus 5 molar at the end point, thereby introducing a positive determinate error. However, it has been proved experimentally that even with concentration as low as 2 multiplied by 10 to the minus 3 molar, the extent of error caused is negligibly small. Adsorption co-precipitation phenomenon using fluorescein, dichlorophosphorescein, and tetraboromofluorescein or eosine essentially impart the fluorescinate ion that is absorbed on the silver chloride particles. At the equivalence point, the silver chloride particles change from white to pink due to the co-precipitation of a silver fluorescinate. In short, the adsorption indicator method is quiet, rapid, and capable of providing very accurate results for the estimation of chloride with silver nitrate. Furthermore, boromide, iodide, and thiocyanide ions can also be titrated with silver nitrate, employing eosine as an adsorption indicator. How is the assay method? I try to take another video, but in this part of the calculation I am so confusing, and I'm just now trying to understand this part by the theory, how it's happened, how it's calculated these parts. I should coming to the practice. Okay, if anybody of you, of my listener by my video YouTube, if you understand this part, please explain it for me. What's happened here? I'm confusing now. I should search it a lot now to understand it by myself. Actually, because I'm learning by you a lot, because lots of things distract me. I choose this video YouTubing to learn by myself and study. Okay, I hope that you enjoying and have a good time. Now I'm in my pharmacy and I study with you because I don't have any patient and there is a COVID-19 condition. Okay, have a good time. Bye bye.